This is Unit 10, Lesson 4. It's transformations on the coordinate plane. So it's just how you transform figures in quadrant 1 of the coordinate plane. SAB page 221 to 222. Okay, so just to start out, to translate a figure means to slide it to a different place on the graph. So triangle PQR has been translated to the right. Right, it's slid over, and you could say exactly how far it slid. It's gone over 1, 2, 3, 4, 5, 6, 7, right? It's gone over 7 places to the right. So you can be pretty specific about what's happening with those shapes. So the different distance from P to P is 7 units. Okay, the distance from Q to Q will be 7 units. Right, so it's just counting these, or the other way you could do it is take this Q, it's 10, and subtract 3 from it, you get 7, right? Take the R point, 12, and subtract 5 from it, and again you get 7. And we're just talking on this x-axis because it wasn't translated on the y-axis, it was translated across the x-axis. So triangle PQR has been translated 7 units, there are 7 units between each one. It's a little bit repetitive there, right? So it says up 5 units that we're going to translate it. Okay, so just come here and go up 5. 1, 2, 3, 4, 5. Put your dot. That's going to be P. All right, up 5. It's going to put it in that same spot. That's P. R. Okay, and then up 5. 1, 2, 3, 4, 5, and that's Q. Okay, and then you can connect those, and as you connect your points up, you'll end up with that triangle that has now been translated up 5 on the y-axis. So where are the vertices now? And when you come up here and look, you've got P at 1, 9. So I'm going to come down and put 1, 9. You have Q at 3, 7. So I'm going to put 3, 7. And when you come back up and look, R is at 5, 9. So 5, 9. So what is the numerical relationship between the coordinates for PQR and its translated coordinates? Well, the x coordinates stay the same and the y coordinates are 5 more. Okay, because we've translated the image on the y-axis. So, ooh, that's too big. Let's go smaller. The x coordinates the same while the y than the all right. Okay, so when you reflect a figure, it is taking the same distance, the point's the same distance, but it's across a line. So it's going to look the same. Remember, the shape actually kind of looks different. It's like flipping it over the line. So if you took it and you actually physically moved it over the line. So the first thing we're going to do is plot a point at 6, 9 and 6, 12, and using our ruler, we're going to draw points through it. So I'm just going to use my straight edge here. I'm going to make it a different color. Okay, and I'm going to draw it on 6, 9 to 6, 12. Okay, so this is the line we're going to reflect across. Okay, so reflect it across that line. And we're going to start by making sure that all my points are an equal distance as I reflect it across. Okay, So I need to be 1, 2 away from the line. So I'm going to go 1, 2 away from the line. Well, there's W, and then it's 3 back. Okay, and then I'm up to here, and I'm actually over to here. Okay, and then I'm going to connect those points. Okay, do you guys see how I just figured out how far away from that line that I was reflecting across I needed to be? Okay, so there's my new shape. And then we're going to say what those points are. Okay, so what are the vertices? Well, we have 11, 9. We have 11, 12. We have 8, 9. Notice how I always do the X first, and we have 9, 12 in my ordered pairs. Okay, plot a point through 1, 6 and 4, 6, and then use your ruler to connect it. Again, I'm just going to use my straight edge, and we'll make that a different color again on the 6. Okay, so 1, 6, 4, 6. So this is the new line we're going to reflect across. Okay. So then it says reflect this one across that. Okay. Well, when I reflect it, I need to be 1, 2, 3 away, right? So 1, 2, 3 away. Put my S dot. I'm gonna bring W down. Okay. That being said, then I go up 3, which puts me on 1, 0, and 3, 0. And then I'm gonna again use my straight edge and connect my points. And I have my new shape that's reflected across. So we're going to now write what those coordinates are. Remember X first, then Y. So we go 1, 0, 3, 0, 1, 3, and 4, 3. Okay, so you guys just see I'm just identifying the points on each corner, the vertices where they meet. So the trapezoid's reflected across the vertical line and the y coordinates remain the same, but the x coordinates change. When it's reflected across the horizontal line, the x coordinates remain the same and the y coordinates change. So that's your answer to number 12. Replay if you need to.